We want to look at a couple of examples today of reflexive property and vertical angles. And we've talked a fair amount about reflexive property and vertical angles already, so let's just review what this is, what these two definitions are. The first one being that a line segment or an angle is congruent to itself. So this is the reflexive property. And as you've heard me say before, what happens with the reflexive property is if you look in the mirror, you see your reflection. And in other words, when you look into the mirror, you see yourself. So reflection and reflexive property are very similar. Reflexive sounds like reflection. And then vertical angles is our other review word here. Two angles are vertical if they're opposite angles. So like angle 1 and angle 3 are opposite of each other. They're opposite angles formed by the intersections of two lines, and vertical angles also happen to be congruent. Not only are angle 1 and angle 3 congruent, but angle 2 and angle 4 are also vertical and therefore congruent. So knowing those ideas, when we come down here and look at a couple of proofs, I want to remind you that marking up these pictures is very, very helpful when we're working with these types of problems. So we're given that AB is congruent to CD and BC is congruent to AD. And if you notice, our first two statements down here deal with the given. So we're just going to fill in the given. And even if you can't fill in everything in a problem, try to fill in what you know. But once we identify that these are given reasons, let's go and mark up our triangle. And actually, the triangle is marked up. AB is congruent to CD, and BC is congruent to AD. So there are those two markings. But then the next statement here, which is given to us, says AC is congruent to AC. Well, AC is congruent to itself. That is the reflexive property. And I marked it up in the picture already. So what we can say now is that triangle ABC is congruent to triangle CDA because we have a side from each of the triangles that's congruent. We have a second side from each of the triangles that's congruent, and then the third side is also congruent. The reasoning is side, side, side. When we look down here at the next proof, it says that B is the midpoint of AE. It also says that B is the midpoint of CD. And when we start here, B is the midpoint of AE. That was a given piece of information to us. So since B is the midpoint of AE, what we can say is that AB, segment AB, is congruent to segment BE or EB. I guess I'm going to go EB for now. This length and this length are congruent because of the definition of midpoint. That's what midpoint does. We also have B is the midpoint of CD. Well, that was our other piece of given information. So we can make a similar kind of statement as we did in statement number 2, which is that DB is congruent to CB, Again, the reason is definition of midpoint. Let's mark that up in the triangles here. We've got this, and we've got this now. So at this point, we've got triangle ABD is congruent to triangle EBC. And as we take a closer look in there, what we see is that those are vertical angles. And what we can say is that vertical angles are congruent. So now when we look back up here, we have triangle ABD is congruent to triangle EBC. The reason being, we have a side that's congruent in each of the triangles. We have an angle that's congruent in each of the triangles. And then we have another side that's congruent. So we can say side, angle, side.